Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to talk about the synthesis of alkenes from alkynes. Now, this is going to be for an acid-promoted reaction. In general, acids add across one of the pi bonds of an alkyne, remembering that alkynes have two pi bonds. When you add this acid, for example, hydrochloric acid, will deprotonate the acidic proton, and then you'll be left with a vinyl cation. That vinyl cation can then have the halide itself or water add directly to it. In general, these reactions favor the Markovnikov addition, but they give a mixture of E and Z isomers, and we'll explain why in the mechanism. In this reaction, we have 2-butene reacting with hydrochloric acid to afford the two alkenes shown on the right. Notice the product on the top is a trans product, while the product at the bottom is a cis product. Let's talk about the mechanism. So the first step is that the alkyne will attack or deprotonate the hydrochloric acid. Which looks like this. Now I've drawn this structure with a slightly incorrect geometry to highlight the point that the hydrogen is adding to the carbon on the left, and what's left over is a vinyl cation. If we fix this geometry, you'll notice that the methyl group points up while the cation points down. That cation is basically an empty p orbital, and that methyl group can switch from up and down. Both of those are possible conformationally speaking. So there's an equilibrium between these two structures. In the last step, the chlorine, which I'll show in red, can attack the cation. Okay, and if it attacks if it attacks from the bottom, as we see here on the left, that's going to afford the cis product. And if it attacks from the top, it's going to afford the trans product, without any preference for the trans or the cis product, since both of those conformers are energetically or almost energetically equivalent. Some questions you might want to ask in office hours. One, can you get a mixture of vinyl chloride and vinyl alcohol? And if you make the vinyl alcohol, can that tautomerize? That's going to be the subject of an episode that we'll do right after this. And finally, can you control the cis to trans ratio in this reaction? So with that, that's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.